listen carefully to me. This is a program that I've written already. However, you are also we are going to be writing the program again, and we are going to be using the same software to write the first lane, and we are going to be using this same software to write the second lane. And why the first lane is on green, the second lane is going to be on red, of course. And then when they are changing as well, of course it's going to be yellow. They're going to be having our amber in between while these things are changing also. So that's also very, very, very important for us to know. Okay, so sorry, this platform is not just running on this training group alone. We are also running on a lot of platforms. Okay, so you might want to bear with us if I'm a bit slow. As I'm talking, we are live on Zoom, we are live on YouTube, we are live on Facebook page and just a Facebook group. Okay, so we are going to be starting now. If you have any question, you can drop on your comment section. In any platform you are watching us, just drop on the comment platform section rather, and I'm going to be answering all your questions. If that being said, this is 6:30 already, so we are starting the class. Okay. Oh, we have a lot of people on Zoom too. All right, so good. Now, as you can see, this is my software that I'm going to be using for this class. Okay, and I'm going to be, first thing is this. If you have not used this software before, let me quickly take you through it. For you to write, this is our writing platforms, so where we write the program. This is an operational panel. Okay, this is our PLC here, and of course we have our light as well. So to write the program, firstly you have to click on edit ladder. That's the first thing when you want to write the program. You click on edit ladder, then you are going to write all this program to get this done. Okay, and because we are writing 2-lane programming today, that means when this is on red, then we can also have some on green here, of course. So I'm going to delete all this program, then we are going to write it together. Yes, because I can't write it alone. But let me just take you through the previous one we've done in the last class. All we did in the last class was very, very simple. Okay, here we have a push button X20, which is tied to this push button here. Okay, and then this X20, we on our output Y0, which is attached to this red light. Okay, with a timer. Okay, this is the timer 10 set to 100 seconds, which means after 100 seconds we ask this timer to cut off this first light. Okay, and this same timer is an input to put on our second output, which is the Y1, which is called yellow, or some call it amber. Okay, that timer is going to put on that same yellow at the same time putting on another timer, which is just going to run for 50 seconds. Okay, and after running for 50 seconds, it's going to put off himself. Okay, you can see the same address T1 putting off this entire unit and itself. Then that same one, okay, is going to put on another section, which is the green, and then put on the green on another timer. Okay, put off yourself, and the last timer, which is T2 here, is that put off the last light, is going to be an or statement at the beginning again to recycle the light. Okay, so let me write to the PLC. Downloading to the PLC writing program. Okay, write completed, allow it to load. Okay, and then now you can see my PLC is on green. Then I can press start with X20. Then you see, notice that my program is running. Notice that my program is running and it's going to run alongside the duration that has been set. Okay, that is how long it's going to run. It's going to run alongside the duration that has been set. Okay, great. Now that that's been said, then we need to now write this program from beginning. Okay, welcome. How are you? Okay, now great. So we are going to be writing that program from the beginning. We're writing that program from the beginning. Yep. Hello. How are you? Yeah, fine. Sorry if I'm disrupting with that. We have a lot of people greeting from here. We have about 6 different platforms we are streaming at the same time. Okay, so sorry if that is disturbing. Okay, so that being said, then I guess we can proceed with the training. So I'm going to click on edit ladder. Sorry, people on Zoom, can you hear me? Please, the people on Zoom, can you hear me at all? Oh yeah. Solomon, everybody on Zoom, can you all hear me? Okay, I think they can hear me, so we continue. I'm going to share with the people on Zoom directly the software, so they can as well see it. Great. Okay, good. So now we are going to be editing the ladder. Then we are going to be writing all this program again. So I'm going to click on delete. 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 Delete this. Delete everything. Okay, and then we start again. It's pretty simple. Just follow me one after the other. If you are not getting anything, just please send, just say ask questions online. Just drop your questions. I'm going to be as much as possible very simple so that everybody can hear. The essence of this class is not for me to prove if I'm the best programmer. The essence of this class is so that you can know. So please, as much as possible, if you are not getting it, just draw me back. We have this class till 8:30. Okay, so now that being said, what we want to do today, let me show us what we want to do. Okay, what we are all doing today is what I just displayed for you on the screen. Only people on Zoom will be able to see that via my camera alone. Okay, okay, good. So that is what we are going to be discussing today. 2-lane traffic light programming. And then we want a situation whereby we can be able to do that programming together live now. Okay, now start. You have to click on edit ladder. Then the first thing to take is your normally open button. Okay, your normally open button. So I'm going to click on this, and then we are using this button as our input, X20. PB1 means push button 1, and the address attached to this push button 1 is X20. That is a PLC input address. From here, you'll be able to see in X. In X means input X. Out Y. Out Y means output Y. So everything representing Y here is an output, and everything representing X here is an input. All right. So that being said, we need an input of a push button, and this is PB1, address attached to it is x20, so I'm going to type x20 there. Okay, and then press OK. Good. So that is pressed. Then the output y0, this red light, y0 is the address. Okay, y is the, it means it's an output, 0 means it is an output 0, and red means just the color of the light. Okay, and so I'm going to put, oh, false. Sorry. Before we do that, I guess we should also test the light, the color of the light by this side, all this y20, y21, y22, y23, so that we can know which one is our red, which one is our green on this other side as well. So let me type y20 first. Y20. Okay, let's use switch to test. So we use x24. You have to convert, then write to PLC. Okay, good. Then let's on our switch. Oh, great. That means y20 is our red light. We need to write that down. Y20 is our red light. For everyone that have the software and also writing their own program too online, please just note it down so that we will not have to go back to that again. Now that we know that for the other side, y20 is our red light, then we need to check for the other one too. Okay, y20 is red. Then let's edit ladder again. Check for the second one. The second one is y21, so just remove the 0, put 1. Press OK. You have to convert again. Write to PLC. Press OK. Then let's put it on back. Oh, y21 is blue. I'm not sure we need blue, so let's check y22. So edit ladder, double click this and delete 1 and put 2, and then here you just have to convert. Then you write to PLC, then you press OK, and of course, so now let's on our switch again. Oh, y22 is yellow, so you can also write that down too. You know, this is not attached, there's no address attached, I mean there's no color indication attached to them, so you might not know that. So y22 yellow, and I'm guessing that y23 will be green too, but let's just test it also. These are necessary things that everybody must do, even when you are working with a physical project. You've got to test all your devices that you are going to be working with in the project, so that you will not have issues when your project is almost finished. So press OK. All right, so clicked on this. Now y23 is green. Okay, great. So now we get started. Now. So first thing, let's delete this. Okay, but we have not done anything. A lot of people are asking questions already. No. Let's at least do some things before you start many questions. Unless you have issue. No audio. Oh, really? Please, if you are on Zoom and you cannot hear me, please just unmute yourself and tell me now. Please, if you're on Zoom and you cannot hear me, please let me know. Or if I'm not hearing from anybody, then I will move on, please. Hello? I guess people on Zoom should be able to hear me. Wahab, can you hear me, please? Just send a message so that we can continue this class. You can hear? Okay, thank you. Thank you, Wahab. So we continue. Please, Mr. Kindness, check your check your own personal device. I think I issues from there. Okay, so we start. Now, the first thing is to put your input, and then that is x20. Then to our output, which is y0. Pretty simple. So you use a coil for your output with the address y0. Okay, then we convert. Because we have a lot of new people for this class also, we might want to quickly explain difference between a switch and a push button. Okay, now, and that is what you are going to see now. Before y testing, we just put an address of a switch here, and anytime we press the switch, the light come up without issue. Now that we've started our program, we are using a push button. If I press this, can you see that the light comes up, and whenever I release my hand, the light went off? That is because it is a switch. A switch is a spring-loaded button. Okay, is not expected to retain signal. For it to retain signal, then you yourself need to do what we call latching. Okay, you have to latch it for you to know that, okay, oh, this push button is now working like a switch. All right, so that being said, then now we need to latch it. So how do you latch a push button or any output? Very simple. To latch it, you just need to put the address of your output under your input. Very simple. You have to put the address of your output under your input. So to do that, I will do that for us now. Edit ladder. You click here. You choose open branch. The address I have here, which is y0, you put there. That is exactly what we are trying to latch. Then you convert right to PLC. Okay, and you press OK. Now let's test it. If you press on now, can you see that I don't need to keep pressing? Immediately you press on, it comes up and it will remain on. Why? Because you have latched it. If you have not latched it, it will not behave like that. Okay, for it to behave like that, that means you have to latch it. Okay, if you all understand that, then we need to now move forward in our program. Okay, now that we have latched our program, our output, the next thing is we attach a timer to it. This timer that we are attaching to it is going to do a very simple job. It's going to set the duration to which the light will remain active. It's going to set the duration to which the light will remain on. Okay, to do that, all you have to do is edit ladder again. Then here you can just use what we call a vertical line. Okay, just press OK. Take your box down, create an output. Now, a lot of people used to ask me question about this timer. It's very simple to do, and listen to me very carefully. In a PLC, we have up to 256 timer from 0 to 255. So you have ability to use from T0, T1, T2, T3, T4, T5 up to T255. Okay, so for this, I'm going to be using T0. I'm starting with T0 space. Then I have to now give him the amount of time he's going to use, like the duration for the timer, as far as this particular software is concerned, which is FS Trainer we are using. So T0, you press a space, you give K to indicate duration, Then for this, I'm going to be using 100. So after pressing 100, I'll press OK. Then here, I'll put the normally close of my timer, which is T0 here. Okay, pretty simple. You convert, you write to PLC, okay, and then you press start again. So let's press start again and see. Now, did you notice your timer is counting? Okay, and after the timer has finished counting, it's going to put off the light. That's what we're saying. Let me take you through that again. When you press your push button, it's going to put power here and here. After the timer finish counting, the normally close of the timer that is here is going to open, and when it opens, it's going to put off the light and reset the timer automatically. Okay, that being said, this has been treated last week, okay, but we just need to go through it before we continue for our 2-lane traffic light. Now you click on edit ladder. Before you go, don't forget you have attached a red light here. Then we also need to attach a green light for the second lane. Why? When the first lane is on green, then definitely the second lane has to be on red. So here I'm going to attach the address of red, which we know as Y20 here. So I put Y20, we press OK, and then we convert, then write to PLC. Okay, great. So now let's look at that. Oh, can you see we have red, okay, which is going to be something that is very wrong. Two lane cannot be on red at the same time. One lane has to be on red while the other lane is on green. So edit ladder, you change this address to Y23. Convert, write to PLC. Okay, and here we go. Wow. So why we have red here on this lane, on the other lane here we have green. So car can keep going here while car is waiting here. I don't know if you get that. That is the first phase of it. That is the first phase of it. Now, to go to the second phase, you click on edit ladder. The same timer that is putting off this red light and green light and resetting himself at the same time, this same timer will serve as an input, okay, T0, to another set of light. So, and then the output this time is going to be our yellow, which is Y1. Okay, and then we have to set a duration, of course, for this one as well. So for this timer we are going to be using is going to be T1. You cannot use T0 again. So we say T1. Okay, this is just a number. We can just use like a 50. Yes, no, 30. It's okay. Okay, 30. Okay, and then we are going to be attaching the address of the second amber, which is here as I think is Y22. Yeah, so Y22. Great. Then we are going to ask the timer to put off the first to put off themselves and reset itself. So we're going to put T1 here. So after this guy has finished counting, he's going to open this line. So control, then write to PLC. Then we press OK. Okay, great. So let's look at how it's gonna work now. Wow, can you see that? Can you see that? That is exactly what we are saying. Okay, for people that have the software and are also practicing at home, you can swear continue and follow me with it. Okay, and so now let's continue this. Oh, for people that ask a question already on Zoom, please you just have to wait a bit. Let's get this program to some level, then we are going to attend to all your questions. I'm sorry if answering questions is not possible for now. Sorry for that. All right, that being said, so let's continue. Press again. Okay, so edit. We now say this same timer here that put off this session, we put on the last session. So here we say T1. Okay, putting all the outputs Y2. Okay, with a vertical line. Okay, and then with an output of course T2 now K100, and at the same time we need you to put on the red light for the second lane, which is Y20. All right, then we have to put a normally close of the timer here, which is T2. Then we convert, then write to PLC. Okay, completed. Then we press start again. Let's look at that. Okay, so when this lane is on red, the second lane is on green. Oh, why is our yellow light not working? Oh shit, our yellow light is not going to work because we did not latch the output. Can you see the output here? We didn't latch it. Okay, so we need to do that. Firstly, we need to latch the output, so we are going to latch it with Y1. Edit, add, here put an open branch and put Y1. Then let's convert. Okay, that same thing is going to happen here too. Let's put Y2. Then let's convert, then write to PLC. Okay, so let's start again. Can we start the program? Yes. Now, when this lane is on red, this particular lane is on green. People keep going, keep going, keep going. Of course, and after a while, you see switch to yellow, telling both lanes, slow down please. These people stop and these people going. Fantastic program. That's two-lane programming, but it's not completed yet. It's not completed yet. Look at that. After green finished, did you notice that the whole system went off? That is not how a normal typical traffic light system works. Even while it has of course finished for session, it has to continue to work. It has to continue to work. So for that to happen, click on edit ladder. Then we are going to be using the last timer here, which is T2, to become an off statement here. Okay, so I'm going to put an open branch, and of course I'm going to put T2. Normally I used to use Rising Edge with it, but because the last time we had class, one of our students challenged that we should use a normally open, so we are going to be doing that now. Now let's watch and see how it's going to work. Now red, then I expect it to go back to the previous one. Wow, can you see that? Going back to the previous one, that tells us that it's working perfectly. It's working perfectly, and it's going to continue to recycle itself like that. Like the program is going to continue to work like that. However, this is still not yet perfect as far as I'm concerned. I expect that when the light is moving yellow and then to green, or from green to red, we ought to have yellow in between. Okay, that's what I'm thinking. We ought to have yellow in between. And so since that is not there now, then we need to put it. So that's the next thing I guess we can do. Then we can take in some more questions from people. Okay, now let's look into that. Okay, somebody just has a question on Facebook now. If you need the software, copy the number on your phone or your screen now, then message the number on the WhatsApp. Then we are going to add you to our group. Then you are going to get the software free of charge. Okay. Everybody on Zoom, you have question? Please ask your question before we continue. Just 1 minute more for question, then we move on. For people watching on the Facebook group PLC training class, then you want to, of course, ask your question too. Okay, Ashit Zegzena asked, which software is this? We've replied that already. The software is called an FX Trainer software. Message the number on that your screen, then on WhatsApp, then we are going to respond to you and give you the software. For everybody that has gotten the software, they all know that the software is free of charge. All right. Okay, so we continue. Edit ladder. Then now we can say, first of all, let me reset this so that every light goes off. Instead of having yellow here, can we introduce a memory and call this place M1? For the second lane as well, we call it M2. Okay. And instead of us having Y2, okay, of course, so that means when it's moving from the first one, which is red, green, move to yellow, then from yellow to red, green, then we expect from red, green back to yellow before going back to the first one. So we go here, and of course we are going to put here the last address T2 is going to put on this time around M3. We are going to time the memory and then set a duration of T50 as, oh no, T30 is okay. Oh, T30, sorry, I have to put the duration, I mean T5 K30. Great. Then I put the second memory for the second lane, okay, which I can call M1, M2, then I can call this M4 because, okay, so here we use M1, M2, so this should be M3. Great. So we have this, then T, the timer T5 is gonna be and then here we are going to have T5 because T5 is the last timer. Okay, great. Then we go forward, then write to PLC, then let's see. Okay, so we'll press OK now. Good. Then let's start and see how it's gonna work. Now we are on red. Oh, we didn't have yellow, so that's bad. That's bad. I'll tell you why. I'm gonna tell you why now. We've assigned a memory for that case, and yet we did not we refused to send that memory power to our actual yellows. So what we're going to do here is this: the first memory M1, okay, will be equal to Y22, and the second memory from the second line can be either M3 or M4. So I'm going to take M3, great, and I'm going to be adding this second yellow, which is Y1, great. So I'm going to be converting, then write to PLC. Okay, so now we start. Let's see how that works now. Still counting, then after, oh great. So now you see we have yellow, then to green, then I expect back to yellow before red. That's it. That's it. Then yellow to green, then sorry, I think there's an error there. Let's see that. Back to yellow, then we expect to go to red. Oh, it's not going back to red, then we need to know why. Okay, so let's trace that error. First of all, I don't think we need this at all, so I'm gonna delete this. Just delete this out of the way. Press delete. Okay, great. And here we don't really need the second memory as well here. So because the memory can actually use in multiple ways. Okay, so we remove this as well. Let's convert first. Then let's check. We say X20, we put on an output Y0, which is red for lane 1, and of course will be green for lane 2. We set a timer. We said the timer should cut off both the light and the timing after the duration has been finished. Then the same timer, put on another section here. Then of course put on M1, set a timer. That timer put off itself. Oh sorry, we didn't latch it here. That's one of the errors. So that's one of the way of troubleshooting. So this now, let's change the address to M1. Great. Convert. Then let's move forward to debugging our program. So this timer finish counting, put off itself on another one, and then which is Y2. Okay, Y2 is our green light. After finish counting, the same T2, this T2, put them off, put this on. Oh, then this is not latched as well, so we need to latch this M3. Convert. Then we move forward. Then we say put M1 and M3 should now put on Y22 and Y1. Okay, so let's try to PLC again and see what will happen. Great. So let's see. Green, the time is still counting. Yellow. Then we expect him to go back to yellow. Yes. Then after then go back to red. Oh, great. Nice working. Now he's working very fine. Yes. This is what a two-lane programming means. Okay, this is exactly what we've promised for this PLC programming class. That everybody's going to learn a two-lane programming class, two-lane traffic light programming, and that is exactly what we just deliver now. If you have any question, this is question time. Then you can ask us question. Then we are ready to answer all of your questions. Okay, you have any question, please ask us on this particular program that is just written now. We are here to help. We are here to add value to you. You can as well follow our Facebook page at Light Automation Academy. Please try your best to support us and subscribe to our YouTube channel. Of course, we are live on Instagram as well. So every platform we are there. Just message us, and we'll be glad to help out on any issues relating to automation, programming, consultancy in any part of the world. We are gonna be available for you. Okay, that being said, let's go back to check for questions. If not, then we are going to be ending this session anytime soon. People on Zoom, do you have question on Zoom? For people on Facebook, I'm not sure they have any question. Let's check our YouTube if there's a question. Actually, we have to start from beginning again because last time we had this session, it was so horrible, internet was misbehaving, so we were not able to really give the class as we want. But thank God today we have a very good internet connection, and so we are able to give you exactly what you want. Okay, so we have a question already from Zoom, so let's check the question. Okay, somebody asked a question, and I'm gonna be posting that question straight away, so that everybody can see live. The question is this. Sorry. kindness. On question is we always latch a memory? Very fantastic question. I'll first of all approach the question by saying it depends exactly on what you want to use that memory for. One, two. It also uh, depends on where power is coming from. For instance, if the power to the memory is coming from a switch, definitely is a large already. So you will not need to latch that that kind of memory. But if, for instance, the sorry, if from instance the power is coming from a push button, then definitely you will have to latch it. Okay, so definitely you will have to latch it, and that is exactly how it works. But the if the power is not coming uh, from a large source, then you don't really have to latch it. Okay, and so I think that's a very simple answer to your question. And I'm gonna, if there's no other question, then that can give me opportunity to demonstrate that answer with a type of program. Okay, that's the question. Okay, so okay, I have another question again. Okay, just great question. Must we latch a memory? And then the answer has been given yes. If okay, the person said I'm cleared. Okay, great. If you are still not cleared, of course, we can still discuss more on it. Do we have more questions from anybody, other platforms? If you look in this case, the power coming to this memory is is not a large power. Is like a pulse signal, and for this memory to retain it, you need to latch it. Okay, for this memory to retain that power, you need to latch it. All right, so it's very important that you do latch it, but don't forget what I said. Also depend on where and what exactly you are using it for. Okay, so it also depends on that. Do we have any more question? Oh, somebody from another platform said is not cleared with that answer. That can I expatiate? So I'm going to be expatiating more on that now. Firstly, then I have to introduce us to what exactly a memory is. Then maybe we can change the question to that first. What is a memory in the PLC? So I think that will make more sense to us. So let's do that. What is a memory in a PLC? Okay, some people call it a memory bit. What is a memory bit in a PLC? Now, listen to this answer. Bits are part of the memory of all PLC system. The memory can be retentive or non-retentive. Memory simply means that if power is lost, this person's answer is not correct to what we are looking for. I actually wanted to look for a perfect answer, but the person's memory is talking about something else. Okay, so Oh, great. Now I have a very sound answer from Lex Win. Sorry if I can't pronounce your name. I'm very sorry for that. But let me just go on with your answer. Memory bits are one operand type available for writing a project application. Okay, there are 256 MBs address of memory, and then memory bit hold a bit value of 0 or 1. So that is, in the memory, all you just have is either 0 or 1. It can either be 0 or 1. Okay, and so that means a memory is just it can only be discrete. That is, it's digital. You don't have an analog memory per se. So, and that is exactly what the person just tell us about what a memory is. Okay, so another person still said a memory can also be in a clock format. Okay, so you can have your memory set as maybe at 10 Hz clock, so it comes up and go off automatically on its own, come up and go off automatically on its own. Of course, the PLC we are using also have the ability to do that. Another person said uh, memory is important to be large to store signal. All you just need to do is to send a pulse signal, and then your memory bit is going to retain it. Okay, I think we've been able to really talk much on memory. If there's any other question, then please you can also ask us, then we are going to try our best to answer. And then thanks to everybody that also supporting answering questions there. Okay, now before we move on, since there's no more other question, what I'll just do tonight is this. I'm going to delete all this program. We write it again for the second time. Then we are going to be ending this session. Oh, there's somebody that is meant to join us on Zoom tonight that I didn't see. Mr. Ajani is rightly not with us tonight. Oh, that's serious. All right, so let me quickly do this. Edit ladder. Let's delete all this program and do this one more time. Then we can close all this session. Delete, delete, delete. We are deleting that straight away. So you see, it's not possible to delete everything at once. That's serious. Okay, I can just actually press Ctrl New, but no problem. Let's flow with this. Delete, delete. Okay, while I'm deleting, you can just watch something else, please, so that you don't feel bored. All I'm doing on the screen is just to delete. Then when I finish deleting, I bring you back to the screen. Great. So now we are done deleting. Edit ladder. This time I'm going to be very fast and straightforward with it. So you might not have opportunity to stop me in between for this. If you want to stop, just type your question. I'm going to answer. So X20, or this time I want the program to start on its own. I don't want to be the one to come and start it. So I'm starting with a normally close. Okay. Then to an output Y0. Okay, attach a timer, bring it down. Then you can say T0 K100. Great. Then you can add this. Then you can say Y, this is red here, so that will be Y23. Okay, great. Then I'm going to use a timer to stop that. The timer is T0. Great. Then we'll move to the next one. Then we say T0. Then to the output of my yellow. This time I'm going to use one yellow sign type, not the type that we have to use a memory with. Oh, somebody said I should flow with what I have before. Okay, no problem. M1. and then the output T1K40. Okay. Don't forget we have to latch this, if not it won't work. So Y0, and these two we have to latch this M1. Great. Then the next one is here. There must be a timer stopping this, which is T1. That same timer, put on our next line T1. Okay, it's going to put on our Y2. At the same time, put on the red for this side, which is Y20. Great. And then we attach a time to have a duration for them to remain on. So this time we have T2 K100. Great. Then this timer is going to stop this T2. Okay, great. Then you have your T2. Then the output this time will be M2. Great. Then we are going to have an open branch here as M2. Great. And of course, after M2 also need a duration. So we have T3 K40, because that's the same one we use for the first memory. And of course we put a normally close here of T3. Okay, sorry, T3. Great. Then after which T3, we then have to, of course, go and put on this again, T3. Great. Then down here, then I can now have M1 equal to Y1, which is my yellow light, and at the same time Y22, which is my second yellow. Then of course here all statements M1 and M2, so either of them put you on, convert, write to PLC, press OK. Then we start. Okay, no, it has already started itself. Sorry, we use a normally close. Wow. So we can't use a normally close there because using a normally close has given us signal continually, and that is a very tough time for this system. So use a normally open. Okay, so convert, write to PLC. Then let's see how that goes. Red, count for 100. You can see that here. 50, 40. That's yellow. Goes to green. Then it's going to go to green. Why it's not going to green? Oh, we didn't latch the green. Can you see that? Why? To write to PLC now. Press OK. Great. So start. Okay, so let's see that. That's it. Yellow. Then expect green to come up. Green. That's good. Then go back to yellow. That's it. Then go to red. That's it. So that is just the program we've written again for the second time, and then